let z equal 1 plus 2i and w be 3 minus I. We want to calculate, first of all, z plus w. So that is going to be 1 plus 2i, add 3 minus I. So we're just going to do 1 plus 3 is 4. And then we're going to do 2 add negative 1, which is 1, so we just get I. Then we have z minus w. So that's going to be 1 plus 2i, take away 3 minus I, which is 1 plus 2i minus 3 plus I. 1 add negative 3 is negative 2, so that's the real part. And then looking at the imaginaries, we've got 2 plus 1, so we have 3 i's. And then 2z take away w. So that's going to be twice 1 plus 2i plus 3 minus I. So that's 2 plus 4i plus 3 minus I. That's just expanding the bracket there. Then for the real parts, we've got 2 plus 3, which is 5. And then for the imaginary, we've got 4, take away 1, so we've got 3i. And then we're asked to show the additions on the Argonne diagram. So if we look at z plus w, which was 1 plus 2i, and then adding to 3 take away I. So start from the origin. 1 plus 2i would be this one here. So that one is z. Then in the usual way that you add vectors, we would start at the tip. So starting at the point 1, 2, and we would do 3 take away I, which is 3 to the right and 1 down, which goes to there. And so that one is W. And then the third side of that triangle, that one is the addition. Now the reason it was called a parallelogram law is because you could have done it in the other order. So you could have had the 3 take away 1 and then the 1 plus 2, and so you'd have had this side of the parallelogram here, or these sides. And we can do the others in the same way. I'm not going to do them both, but let's do the subtraction. So where we had the 1 plus 2i, and then we were taking away 3 minus I. So 1 plus 2i, same as it was last time. So that one there is the z. And then we would have minus 3 plus I when we expand this out. So that's 3 left and 1 up. And that vector represents minus w. And so the third side of the triangle there is z take away w. And you can see the answer when we did it algebraically was negative 2 plus 3i, and that's exactly where this point is.